the challenge with this is that all these problems, they live in that white space. They live in the wires that make up the interconnects. And this is a problem because everybody gets trained in thinking about the schematic. They think, everything is about the circuit diagram. And they don't think about the role of the interconnects that can cause these problems we just mentioned. It's the layout itself. You just look at the layout, and unless you're very well trained in it, you can't tell, looking at the layout, what is the impact of the physical interconnects on those signals. And unfortunately, all these issues we just mentioned, the noise problems, they all arise from this combination of the signals going in, those voltages, and unfortunately, we use that approximation of thinking about voltages and currents, but in reality, the way those interact with the system, with the interconnects, is really based on fields. They are fundamentally, the way the world works is based on the electromagnetic fields as described, their properties described by Maxwell's equations. How many of you ever studied Maxwell's equations, at least no test, but just survey? So many of you, and so all my students, they've taken at least one fields class and have studied Maxwell's equations, and they can solve differential equations up to the wazoo with different boundary conditions, but they have no idea what it means. And unfortunately, the way signals interact with interconnects is based on the fields those signals create, how those fields behave with the interconnects acting as boundary conditions with material properties, and that combination generates distorted fields which we translate back into voltages. And so to really understand what's happening with the signals on the interconnects, it's really about how the electromagnetic fields interact. And unfortunately, this is a very complicated way of viewing the world.